Welcome everyone to the People's Debate League. I'll be sharing with you and going over with you the number 360, history of 360. The reason why I'm going to be the history of 360, because the history of 360 is the it will lead to the numbers 33, 666, 144,000, 24, and 12. All those numbers are a part of that number, but you have to understand the history of 360 to understand how all those other numbers play in a part with those numbers and what those numbers come out to be. So let me go ahead. I'm going to share with you the history of 360 and what these numbers mean and how what number 360 means. And later in time, I'll be sharing with you the other history of those other numbers and how they play a part into the history of 360. So let's first start with the history of 360, give you some background on that, how that number actually came about and why that number is used today. Here we go. Share my screen. And here we go. Let me go up here and I'm gonna let this audio thing play. Hopefully you can hear it because I'm a horrible reader and I like to read in silence to myself, not out loud. So let me just work with that right there. I'm gonna go with that right now. Here we go.
Full circle. The long and complicated history of why there are 360 degrees in a circle. Mark Ronan, published in History Today, Volume 70, Issue April 4, 2020. The Ptolemaic System of the Universe from the Harmonia Macrocosmica, by Andreas Cellarius, 1708, copyright Bridgman Images. In school, we learned there are 360 degrees in a circle, but where did the 360 come from? When it is pointed out that the Babylonians counted to base 60 rather than base 10 as we do, people often ask if there is a connection. The short answer is no. The longer answer involves Babylonian astronomy. Like other ancient peoples, the Mesopotamians observed the changing positions of the sun, moon, and 5 visible planets, Mercury, Venus, Mars, Jupiter, and Saturn, against the background of stars in the sky. Before 2000 BC, a scribe in the southern city of Uruk, referring to a festival for the goddess Inanna, made it clear that, as Venus, she could be both morning and evening star, depending on whether she appeared before sunrise or after sunset. For them, Venus was a single object, and they observed its changing position, along with the other planets and the moon. These positions all lie on the same great circle, called the ecliptic, defined by the apparent motion of the sun as seen from the Earth during the course of a year. The reason the moon and planets are on the ecliptic is that, from the Earth's point of view, the plane of the solar system meets the heavenly dome in a great circle, so that is where they all appear. In order to record their motions accurately, 2 things are needed: a fixed calendar and a method of recording positions on the ecliptic. Calendars are tricky. The phases of the moon formed a rhythm in the life of all ancient cultures, and it was natural for the Mesopotamians to base their calendar on months that started on the evening of the first crescent at sundown. With good visibility, a lunar month lasts 29 or 30 days, and by about 500 BC, the Babylonians had discovered a scheme for determining the start of each month. This used a 19-year cycle. 19 years is almost exactly 235 lunar months, and the scheme works on 7 long years of 13 months and 12 short years of 12 months. This led to a fixed method of interleaving long and short years, still used today in the Jewish calendar and everything in the Christian year based on the date of Easter. The records that helped them discover this cycle began in the mid-8th century BC, when Babylonian astronomers wrote nightly observations in what we now call astronomical diaries. These continue until the end of cuneiform scholarship in the 1st century AD, yielding 800 years of astronomical records. Terrific achievement, far longer than anything in Europe to this day. It facilitated great advances, notably their discovery of the so-called Saros cycles for predicting eclipses. Each one is a cycle of 223 lunar months, perpetuated over a period of more than 1,000 years. There are Saros cycles operating today, first seen in the 8th and 9th centuries. They remain the basis for eclipse prediction and appear in detail on the NASA website. Astronomers in Babylon were using Saros cycles by the late 7th century BC. They only needed a lunar calendar to keep track of them, but for more sophisticated work on the moon and planets, they needed a steady, non-lunar calendar. So they adopted an old idea, once used during the third millennium, for an administrative calendar, 12 months of 30 days in a year, making a 360-day cycle. This ideal calendar reappears in the second millennium BC in the Babylonian 7 tablets of creation, which states that the god Marduk set up 3 stars each for the 12 months. These triplets of stars corresponded to 12 divisions of the ecliptic, one for each ideal month of 30 days, but it was an idealized calendar not used in everyday life. The 12 equal divisions for a year also applied for the day from sundown to sundown, divided into 12 baru. For example, in the Epic of Gilgamesh, written during the second millennium BC, our hero races the sun in Book 9, and we are told how he progresses at each baru, eventually coming out just ahead. As with the ideal month, a baru was split into 30 equal sections called us, giving 360 us in a 24-hour period. Each was therefore 4 minutes in modern terms. Fractions of an us were also used. For example, in the astronomical diaries, we find an instance where the first appearance of the moon was visible for 3 3/4 of an us, 15 minutes. An accurate recording of time was important for these diaries, and so were the positions of the moon and planets. During the 5th century BC, a scheme was developed that could be broken down into fine detail. The ecliptic was divided into 12 equal sections, each split into 30 finer divisions, also called us, yielding 360 us in total. For finer accuracy, an us was broken down into 60 divisions. Each of the 12 sections they labeled by a constellation of stars, and, when the Greeks took on Babylonian results, they preserved these constellations, but gave them Greek names, Gemini, Cancer, and Leo, most of which had the same meanings as in Babylonia. As Greek geometry developed, it created the concept of an angle as a magnitude. For example, adding the angles of a triangle yields the same as 2 right angles. But in Euclid's Elements, c. 300 BC, there is no unit of measurement apart from the right angle. Then, in the 2nd century BC, the Greek astronomer Hipparchus of Rhodes began applying geometry to Babylonian astronomy. He needed a method of measuring angles and naturally followed the Babylonian division of the ecliptic into 360 degrees, dividing the circle the same way. So, although angles come from the Greeks, the 360 degrees comes from Babylonian astronomy.
Thank you very much. And I believe that if that be there for you guys, I hope you guys picked up a lot. I know there's a lot that I picked up and a lot more that I knew. Well, I just say this. There's something that I knew there already, which explains a lot. And there's a lot more that I just learned that needs to be researched. And this is definitely a great build. I hope you guys learned and got something from this. I thank you and appreciate your time. And that's it.